Good evening. So my talk is about database performance in Ruby on Rails applications. It's just a bunch of stories that I like to tell. So I'm Leonard. I'm on Twitter as Elchin and on GitHub as L15N. I'm an engineering manager at Cookpad, and we haven't really done an introduction of Cookpad, but so we're a big service in Japan, but we also have an international service as well, and it's currently available in 25 languages in 70 plus countries. So this particular one's Vietnamese. And we've been using Ruby on Rails since 2007. So Ken showed a slide, I think, with an app from about 2008, but there was one before that from around 2007. So as you can imagine, we've been using Rails for 11 years now. So we have a lot of Rails apps. Just to give you an idea of what it looks like, this is a imaginary mapping. It's roughly correct, but you could see it think of it like this. We have a bunch of different types of Rails apps. Some of them are like internal business apps, which are like really complex but have few users. Some really simple internal tools. For example, we have a tool just for doing your LDAP authentication and connecting your GitHub account to your Google account. And a lot of new and preferred products and supporting services like authentication and payments and so forth. Most are Rails, a few are not Rails. And we've got these other two in the top right corner, and these are two cookpads. So you might wonder what these two cookpads are. So as I hinted earlier, one is cookpad in Japan, which is our legacy product, you could say. It's been around since 2008 on Rails, and before that was something like Cold Fusion? No, that can't be it. Something like that. But yeah, it was something else before Rails. And we've also got this international global app that we call it the global app. So these are our two cookpads, and both of these apps are like on the complex side, and there are a lot of users. So just to give a sense of scale, some rough numbers, the Japan app has about 300 controllers, over 1,200 models, and it serves about 60 million users a month. The international app, in contrast, has the same number of controllers, but a lot fewer models, 400 or so, and serves about 40 million users a month. So my talk today is about performance, and what I mean by this is that when you have so many things, like performance gets a bit harder. And usually, because Rails does scale, you can just add more servers and have faster services, and it gets you so far. However, being big apps means there's a lot more code, and it means there are a lot more errors as well. And having a lot more users, it means it's also harder to notice the slow users. And having a lot more data means it's really hard to reproduce some of these issues sometimes. So that means good tools are essential. I see we've got some guys with Scout t-shirts. Unfortunately, we don't use Scout, but we use a bunch of tools which are similar. Error tracking wise, it's good to have an error tracking tool. We use Sentry. Performance monitoring tool, we don't use Scout, but we use New Relic. And it's also good to have some visualization for, today I'm talking about database performance. So one useful thing to look at for that is your slow query logs. So we visualize ours with Kibana and Elasticsearch. So we just dump all the logs in there and have Kibana and Elasticsearch index it for us. So with these in hand, you can solve a lot of problems. So I'm just going to introduce a few problems that I've seen in the past year or so. So these are some database performance war stories taken from our global app. The first one is bookmarks don't load. So what happened was that we started seeing some weird timeouts in Sentry. I'm just going to show you what it looks like. So I had this thing, a rack timeout because I got the middleware in there. It says it ran for longer than 19 seconds. But in contrast, if you just look at our performance numbers, they look pretty good. We've got this average of 62 milliseconds for response time. So things look fine, right? Nice average response time there. The problem with that is the word average. So the problem with averages is they hide the real people behind every single request that you get. Hopefully most of you have done a little bit of stats in the past, statistics. So average, of course, if you have a bunch of requests, for example, in this one, you've got a really low average and even low median, actually. But you've also got a ninth. You can also look at it from the percentile perspective. With this group, of this cohort, the 9th percentile, so the users who are faster than or slower than 9% of the users are at 54 milliseconds. For the 95th percentile, it's 109 milliseconds, and the 99th percentile, it's at a big 812 milliseconds, and the max is 980 here. This is just illustrative data. And what I want to say here is that it's pretty useful for you to think not so much in averages, but in percentiles. So just to recap, by percentiles, I mean the people who are slower than X percent of the users, if I say 99th percentile. So some of the reasoning behind that. So some users are slower and some users are faster, and there's got to be some sort of reason behind it. It's not random. And the key reason, at least for us, is that often these people who are slow because they have more data, so some of their queries get slower. For us, these can be people who publish the most recipes or who, say, bookmark the most recipes. In other words, we think of them as our most active and most valuable users. And they're always thinking, hey, why is the internet so slow? Anyway, back to the 99th percentile here. So I'm sure Scout has something like this as well, but New Relic has a view which lets you look at the 99th percentile, and this is a lot more useful. So in this particular example, the blue line here illustrates the 99th percentile. It's 95th percentile here. Yeah, 99. And if you look closely, it says 514 milliseconds. And this is 7 times slower than the average. So let's have a look at this in context. So this slow query, it comes from somewhere. It comes from our top page. So in this top page, yeah, it loads fast normally. But on the right-hand side, if you look closely, there's some user-specific content here. These are the recipe bookmarks. And as a site with a lot of users, we have quite a lot of recipe bookmarks. I did a query a couple of months ago, and there was about 100 million plus, so that's a decent size. It's not immense, but it's pretty big for something user-facing. Anyway, for the bookmark screen, the implementation of view looks like this. So it says current user, bookmarks, listing recent, and the SQL looks fairly innocent. So you're selecting from the bookmarks and you're ordering and you have a limit and an offset. So because it's slow, the usual thing you think is, oh, probably the query is slow because there's a lot of data. And to figure out what's happening, you can explain locally, just add explain. It's a nice Rails feature. But what I found is that, especially in cases like this, explaining locally doesn't tell you that much unless you have a lot of data. So it's a lot easier to look at the explains that happen in production. You could run it in production because running things in production gives you different results. You have more data, so there's more data, the behavior of MySQL changes and have more load and your queries changes as well. So what I like to do is have a look at the explain that the slow query log spits out. So this is from our slow query logs. So as you can see, there's the output from the explain. It looks a little bit different from your explain you get on the command line. It's just formatted, that's all. By the way, we're using MySQL on AWS with their variant called Aurora, but the same principles really apply to all databases. So what that explain tells us that, yeah, great, we're using an index, that's cool, but there's this problem here. It says using file sort. This isn't good, and also says that it's looking at quite a few rows. So just stepping back a bit, why is it good to use an index? Why is file sort bad? Why does this rows examine thing matter? I'd like to do a quick little dive into relational databases. Hopefully most of you know this, but I'd like to go through it anyway. So a really simplified image of how these things work. So the Rails app queries the database. So we're going to have a look at the database server. So very, very simple database internals. If you know a lot about databases, maybe you can give me some tips later. But this is the easy version. So firstly, if you have a database, all it means is that you've got this data stored as rows on a table on disk. And you also have this thing called, you can also have these indexes, and these indexes are usually stored separately as B trees with the leaf nodes pointing at the table rows. And these B trees, what they are, if you've done an algorithms course, you probably have a good idea of what I'm talking about. It's basically a sorted tree data structure, and it's really nice because it self-balances when you insert stuff and you delete stuff, and it's really fast. So complexity-wise, O log n for searching, and it kind of looks like this. This is an artist's impression. And the little things on the bottom, they're the leaf nodes, and in this case, it's a representation of what MySQL does with indexes, which is the leaf nodes point at the primary keys of the rows. So why is this relevant? In a database, you usually use a select, but what is a select? A select is a search, if you compare it to computer science search. And in order to search, what you want is to have sorted data. Unfortunately, compared to searching, sorting is actually really slow. So even the best algorithms typically are at like n log n or n squared complexity in the worst case. So the great thing is that if you have a B tree index, because it's sorted, it lets you search really quickly without having to scan and sort everything. So with that aside, let's go back to the slow query. So this is the query we were talking about. So why is this slow? We know that it's using index. It's going to use index on the user ID, and that matches the query. But if you look really closely, you'll notice the order by. It's ordering by this visited at. And as a reminder, sorting slow, file sort is slow. So what's the database doing here? What it's doing here is it's actually going to, firstly, because it's got the where, you'll find all the records for user ID from the index, and this is really fast. And then what it does is, despite the limit, it actually retrieves all those records. And it has to sort them, because in order to search, because we've got this visit at order by, you have to sort everything. And then it goes through everything and limits it and returns it at the offset. So what should we do? Well, probably most of you have guessed this, but the easy answer is just use a composite index on the sorted column. Because this is a query which happens all the time, it really benefits from having this composite index. So composite indexes, when they're in the B tree, they kind of look like this. So instead of just having one item you sort on, you have a tuple of two parts. The bonus thing is that if you have composite indexes, they're kind of reusable on a variety of queries. If you have an example, something like this, user ID, recipe ID, and creator that, it actually works for everything. This is what the leaf node looks like here. It works for everything on the left-hand side. So it works for user ID or user ID, recipe ID, as well as the whole thing, the full match. But it doesn't work for anything in between. So if you don't have the user ID in there, you're out of luck when trying to use this kind of index. So my takeaway is that it's a good idea to know how databases and indexes work, but even if you're just working at the high level with Rails. So next one, counting too much. So only a few of you use this though, report some slow page loads. Again, I'm gonna pull up the slow query log. So this is a very similar one from before. So I'm gonna look at the same place, rows examined. That's a pretty big number, 2.7 million rows examined. And the implementation is this. So if you're familiar with Rails, you kind of expect this to use like a counter cache, but unfortunately this one actually triggers a query to the database. Looks like this. So it's counting the number of followers for a user. So to give you an idea what this is trying to do, here's the tables involved, simplified. So you've got this user who's following someone, so it's represented in this intermediate table, and points back at this user here. So it turns out to be a self-referential kind of structure. In Rails, it has many through with user to user through this follows table. Normally you think a counter cache would just work. And that's probably a solution, except we already had a counter cache. And does it work? Unfortunately, it didn't. when you run it here, you'd normally expect there to be no, because it's a cache, the first time it runs, it should send a query, and the second time, it should not send a query. So it doesn't work, it still queries the database. So the next question is, when you're debugging this kind of thing, why doesn't Rails know that a counter cache exists? So this is the expectation. So you got this counter cache on follow, it's set to follows count, and the column itself, it exists in the database, so we should be good. And it increments and decrements correctly, so the value is actually correct in there. So Rails sometimes knows that the counter cache is there. And it follows the right convention as well, so association name count. So in order to really figure out what's going on, we kind of have to go deeper, see how Rails does it. So how does Rails actually implement the counter cache? It depends a little bit on the association itself, but this is the has many version. Inside, there's this count records. And what it does is that it looks at this thing called reflection and sees if it has a cache counter. And if it does, it reads a column, and otherwise it counts everything. This means that this is what we need to think about. Clearly, if it isn't finding the cache, we need to find this thing is returning false. So if we have a look at how it works, if you run this separately in prior, you can actually use this method here, reflect on all associations has many to get the association, and then use that to figure out the cache counter. So what I did was open up Pry, type this in, and if we had a look, it didn't have cache counter, not really what I expected. So even though it's got the correct column, it actually doesn't believe that it's got a cache counter, which is completely counter to expectations here. So diving a little deeper, this reflection object. ActiveRecord has this reflection object which captures the actual association. And in theory, it's got this method that has cache counter, which you saw earlier. And in theory, it'll find the inverse and do something with it. So let's have a look at this inverse, which updates counter cache method a little bit further. So with this inverse, which updates counter cache, what it's trying to do is, in our case, it says the inverse of the association is the follower, so it should inverse of the association with the user is also the user, so it needs to grab that from the class and then reflect on all the associations. So this is getting complicated. Okay, so what the association is expecting is that when you have a has many, it's got a counter but belongs to. And if that's there, then you should be able to find the inverse association. But unfortunately, because this is self-referential, this means that the inverse is actually itself. So it's expecting to have a belongs to on itself as well, which actually doesn't work. So it turns out this is a self-referential has many to many. So there's no belongs to. And I actually think it's a bug in Rails, but I haven't really isolated it enough. So the answer actually is that if you go back to the reflection class, you can actually set the option, and that gives you a shortcut. It's also in Rails guides. And what Rails guides tells you is that if you can't figure out the counter cache, you have to specify it directly yourself. So that's what we did. We added in the counter cache explicitly, and it worked. So this kind of bug requires a little bit of bravery. You need to read the docs and dive into the libraries as well. So last one, out of the database. So yet again, another high traffic endpoint, which is pretty slow. I was looking at the query logs again, and I noticed this little error. So as you can see, there's actually a really huge in clause there. This is not good. So why is this happening? The source of the problem actually looks quite innocent. The method here says like by multiple followees. So what it wants to do is check if a recipe is liked by users who are following the current user. But the problem is if you are following a lot of users. The SQL this generates looks a little bit like this. And here we've got this in clause that we're talking about here, this in at the back. So what does an in clause do? At least in MySQL, it's kind of like an or statement. That means that every time you use it, if you have more elements, each one needs a separate index lookup. And because MySQL, unlike say Oracle, it doesn't have a limit on the number of elements. You can add a lot of elements. And unfortunately, index really won't help you. So when in this kind of situation, just playing around with SQL won't really get you anywhere. So you have to kind of look for another way. Going back, for this, what we really want to do is just see if a person was liked by if a recipe was liked by multiple followees. So we actually only want to do a comparison here. So we don't actually have to get the full count. So instead, we can rephrase the feature like this. Users who like recipe who are also users followed by the current user. This is also a logical intersection. So instead of asking the database to do it, we can pull it out. And because we have an index on there, just doing a pluck and then doing an intersection means we have two fast queries and an array operation, which is actually pretty fast for most reasonable array sizes. So my takeaway there is that sometimes you can't optimize, you need to rethink the thing you're trying to build. So think a bit outside the box and trade off between the database and the application. Thanks for listening. Any questions?
Thank you. So for the second one, where you actually hunted down that issue where because you had a self-referential reference
Yes.
association,
Right.
self-referential association, that the counter cache wasn't going to work without some help. How long did it actually take you to go through that? Are we talking hours, days, weeks?
That was a hours scale kind of thing.
Okay.
So because we figured out that it wasn't working, the next question is why? And the way Rails is set up is that, fortunately, Active Record is built with a lot of logical classes, I guess. So figuring out that the counter cache was there, it just required a search of like where Rails actually implements counter cache, and that's actually very limited. It's only in a bunch of classes which call the counter cache methods. So that means that your search space is actually quite limited. So all I did to get started was look up the methods which let you look up the count. So go from size to say, okay, what does size call? And from there, it goes, okay, do we have a counter cache? Do we not? And there's a small decision tree for you to go down. So I think I only looked at about 5 or 6 classes to get to the root of the problem.
Were you just reading through GitHub, or did you actually like have? I saw that you got pry there. So did you actually have pry in your running instance to find the actual Ruby files where the stuff was being defined in the middle of your call, or were you just thumbing through GitHub?
So what I did was I guess it's like the scientific method. You do a little bit of research first and see what could be candidates for the problem. So the solution wasn't the first thing I found. Like I found a few other candidates first, and what I used pry for was to test my hypotheses in each case, right? So I tried to simulate what's going on by grabbing a model from the database and then calling those methods on it to see what Rails was doing each step of the way. Unfortunately, Rails isn't the big ball of mud it used to be, so you can, as I showed there, call the reflection method and actually get the reflection out to get the association object that gets generated to generate the queries. And from there, you can inspect it and see what's going on. Okay. So yeah, it's a combination of pry and coming up with a few possible solutions first.
Thank you.
Yeah, good talk. So On the first problem, I was surprised that the solution was just a composite index, because looking at the query, where the first thing that came to mind was the limit and offset thing, which I assume is used for pagination in that case. And as you know, I'm sure limit offset pagination is a known bottleneck in some cases. So is this something you explored as well, to switch to cursor-based pagination?
Right. So the ideal is cursor based, but depends on the use case, right? So if it's a web page, then it should be paginated. In this particular case, because it's a infinite scrolling kind of thing, um, that probably would have been a good idea, like as a, especially if it was an API, like having a cursor based pagination would be a superior solution. In this case, um, since the user kind of can update the bookmark, because that is the like last visited thing, it does update frequently enough that like the paginated solution is like good enough most of the time. And I guess the big lesson is that what I found like with Rails projects is that a lot of people don't realize that you can use a composite index. So, and I think that comes from not really knowing why indexes are structured the way they are structured. So what I do see a lot is people putting on an index for every single column that appears in the query, and that just doesn't work. So that was the main motivation behind this demonstration, really.
Thanks.
Regarding the last one, after you do separate query and then merge it on Rails, on Ruby, do you notice any CPU usage or memory usage getting up?
Not really, because it isn't our only like query on there, so it doesn't really dominate the requests in that particular case. So it didn't really. It is a trade-off because you're moving it from the database, but because you can scale out web service way easier than you can scale out databases, it ended up being a really pragmatic solution.
I see. Thank you.
Going back to the composite index, I got a question about this one. You mentioned it in the slides. When you have a composite index, you can use it like starting from the left. And a lot of junior developers don't really understand that part. And when we use composite index, like sometimes they end up writing queries and like, oh, I have an index and it doesn't work, and they don't get it why. And I believe that if you have an index on the ID and also an index on the date in that case, your database should be smart enough to use both of them separately. So it will do like a query on each and then do an intersection on the result set internally. So why would you recommend in that case a composite index versus simply independent indexes?
Well, in this case, it like if you have two indexes and say they're trying to filter the number of results, then some databases will be capable of combining the indexes and reducing the number of results you have. However, in this case, because it's a sort, when if you have a sorted list, all right, it doesn't really help you to have two indexes do it, because what you're doing with an index is you're finding a short way to retrieve the records so you can do something else with it later, right? So if you have two indexes, you can't really apply the sort from one index to the filter of another index. So bring it back to how like everything's really just a computer science sort or search algorithm. And it's very difficult to actually do more than that. So you're just putting together these building blocks in a sense. And unfortunately, a lot of the time, the DB is as smart as you'd like it to be. Like it can optimize, but playing with multiple indexes only has rarely helped me. and it only really helps if you're doing joins and so forth, in my experience.
Like, would you like you do a trial and error? Would you do that also, like when you try something with indexes? Like, for example, try it with a composite index, see what's the performance with that, see if different patterns might lead to different kinds of performance, or you went directly knowing like that's the way that's going to work and went with that solution?
Okay, so in this case, I did have a rough idea, but you do test it. So you do try it out, remove the index, add the index back locally with a reasonably large data set, and try and simulate it. That's what I usually do. Sometimes, though, the explain isn't always enough, because I found that if you have a really big data set and one user has like, say, 1,000 items and the other has like 10,000 items, and you do the same query, the optimizer does a completely different thing. So in that case, the next tool I tend to use is the what MySQL has. It has a trace mode, and if you turn that on, it lets you see what the optimizer is doing, and it shows for each one like what guess it does to choose the right index. Because when you have more than one index, MySQL needs to choose the right one. And what it does at a very brief level is it looks at the index and estimates the number of rows it touches. And the fewer rows it needs to touch, the better. Because it just means that it needs to retrieve fewer things from the database. So that's usually my next step after trying things out and being confused. I'll break out the trace and see what a trace tells me about MySQL. And more, if it goes that far, usually the best answer is to find a way to restructure the database, because there's definitely a limit to SQL tuning, especially if you're playing with Rails. You don't want to have too much unusual SQL, and you don't want to play with indexes too much, because every index is it adds up when you're writing to it and updating the index.
Any other question?
Thank you. I actually just used counter cache like recently, and I didn't know that was happening, so I need to make sure actually in my code. Anyway, my question is the composited indexes. I encountered that I wanted to like have like multiple composited indexes, and which seems like I was feeling like I'm creating too much indexes, but I wasn't really sure like the cons of having too much indexes, like especially like this composite indexes, because when I run explain command like query on the database, it was actually picking the one like I wasn't expecting. So like, have you encountered those kind of like
That happens a
problems?
lot. Like if you have a lot of indexes, well, first of all, like one of the basic things here is that I introduced this thing to say, if you just have this one index, you don't need to have an index on this, and you don't need an index on this, right? Because you can just use that one, right? The database will be smart enough to choose that one because it's already sorted that far and just needs to get rid of the ones it didn't use.
Okay.
So there's that observational level, right? You know the theory, so in theory, like you don't want too many overlapping indexes, right? And the next thing is, as I was saying earlier, if you use the tracing function, it can tell you why it chooses that one, and it's usually a factor of like not having enough records if you're in development, and maybe having too many records if you're in production. So the problem with doing explains and stuff locally is that if you don't have enough data, then sometimes like it's easier to use this index, right? Because it's smaller, right? The other factor that is used is that if you have this composite index, it's actually bigger, right? Because it's got a higher cardinality, for example, and has more stuff, right? So it can be more complex. So going back to the question of having too many indexes, the classical classical issue is that when you do an insert and a delete, what needs to happen is that you need to update the indexes. So I just mentioned that they're all made from B trees. So what that means is that for each B tree, you need to maintain it, right? You need to remove the record or add the record for each index that you have. And that adds up for your inserts. So if you're an insert heavy application or delete heavy application, it's going to make a big difference. But if you're read heavy, it's not so bad. You probably won't really notice. And the other thing is like confusing the optimizer. So you have these similar indexes, it might choose the one that you weren't expecting. So it's better to have as few as possible, which cover as many of your use cases as possible. At least in the case of MySQL, it does keep statistics. So what MySQL does is that it keeps a register like of how frequently queries are made and like which indexes to use and how many rows were used the last time you queried it. And that's how it makes its guess. So when you're running a database server, it takes a while for it to warm up in a sense, right? And it's got its own cache, it's got its own statistics, and you can see those statistics, right? There are commands in MySQL which will allow you to look at the frequency of queries and so forth as well. So if you're in doubt as to how your indexes are being used, it's useful to have a look at the statistics, right? You can like turn on for an instance or something like that and see if your indexes are really being used in production. It's very hard to do it otherwise.
Thank you so much.
So just one other question. In terms of, okay, so I would assume that when you're trying to troubleshoot these performance issues on the app and consequently on the database, perhaps you're going to have some monitoring software telling you, or you might have a salesperson or a customer or somebody else telling you, hey, this is slow. And then you look, and for example, in your last example, right, where you essentially had a gigantic unbounded in clause, right? You might not have encountered that, or you most certainly would not have encountered that in development because your database is, you're going to have a smaller set of data in dev. So when you're trying to troubleshoot these issues, you're certainly not horsing around on production. So are you actually able to pull down like a very large subset of the database to dev to your own laptop or whatever to try this out? Or are there restrictions that are imposed on you by the company preventing that from happening? Or how do you actually deal with that?
Okay, so we do have a small subset locally, and Dave actually has been working on that. But we do pull down subset because it's useful to have live data or close live data with the private stuff removed locally to get the right feel of the application as well, right? Because if you just have foobar for everything, it just doesn't make sense. But it's good to have that real data. But you're right in that it's really hard to get like real data. So what I usually do is we do get access to what we call like a staging server, test server, which has a clean clone of the production data. And we either can test directly on that, or what I like to do is I might pick a table and use MySQL and do a dump of that entire table and get everything up from testing so I can mess around with it locally. Because you don't want to mess around a shared server with other people playing around it because it can disturb them as well. So that's what I usually do. I don't do the whole database. I just grab specific tables because that's usually all you need.
Thanks.
Yeah, we actually have the option to actually download the whole dump as well, but that's an option that you use only in the last case.
And if you've got a day to spare.
Yeah.
Yeah, so we do specify tables which you can't dump as in, they'll be masked. So for example, we will mask like obviously the credentials, for example, as well as stuff we specify as being secure or private.
Chats.
So this is definitely in the realm of ops. So that's more the area of our ops team, but also the dump script is basically what we use. So when you dump it, you can filter out specific columns and say, let's put that in there instead, and so forth.
There's a gem we're using. I forgot its name. I wouldn't recommend it because basically it reads the SQL dump and writes it again without the filtered data. That's pretty heavy. Any other question? All right. Thank you, Leonard.
Thank you.
Please give us some applause.